We would like to spend some time with you today to give you an overview of how Innovia's ability to manage Solidworks can be utilized in a project environment. Our agenda today will open with an overview of the user profiles that are associated with this user experience. Today, Innovia supports the various user experiences throughout the extended enterprise. Innovia offers solutions that address many departmental needs and disciplines. The collaborative design for Solidworks, or SLW, focuses on the specific PLM needs of the designer using Solidworks as their authoring tool. Capabilities include checking in and checking out design information, searching for existing design information in the PLM system, and generating bill of material information for engineering. Therefore, Innovia V6 PLM manages all aspects of the mechanical design development within Solidworks and a design-to-configure capability which offers synchronization with the BOM structure. Subsequently, this solution extends beyond the design department and reaches into engineering. Including Innovia program management applications into this solution expands the number of user experiences even further. Program functionality allows us to make sure products are launched on time and on budget. Product and project managers plan and track project schedule, detailed tasks, and project deliverables. From the project perspective, users had a difficult time finding project information because it is usually stored in multiple databases and persons' desktops. Unpredictable results are also prevalent due to inconsistent processes and lack of deliverable templates. Another problem is that there are often too many new product introduction failures. This is generally due to insufficient phase gate reviews and poor reuse of prior IP. From the design perspective, there are three top issues that are commonly seen. The first is low engineering productivity, which is due to non-value-added data management work. In other words, the designer is burdened with more PLM activities than design activities. The second issue is limited skill and knowledge sharing. This is generally due to a lack of communication processes within the enterprise. Difficult product development decisions round out the top three. These are generally due to a lack of proper product development analysis tools. Project design processes are as diverse as the applications that support them. Here is a sample of the many applications and disciplines involved. Let's now take a closer look at the project design with the Solidworks process. From an engineering and design perspective, project management defines and tracks the tasks and deliverables. The project management capabilities of Innovia can be grouped into the following areas: template management for projects and processes, work-in-progress deliverables and project content folders, project breakdown information, secured access to information by project role, deliverable-driven task completion, traceable meetings and decisions, product requirement traceability, and the ability to share and assign resources and risk information. Subsequently, Innovia's project management capability can be used to drive the engineering and design efforts of the enterprise. Solidworks Management, or SLW, allows the designer and engineering groups to expose their IP into the PLM system, where they can then be linked to project folders and task deliverables as needed. Innovia's Management of Office Applications, or MSF, allows the parallel management of Microsoft Office documentation, also commonly used in this environment. Let's now take a brief look at the architecture of Innovia as it applies to these applications. The three client components that support the project design user experience all communicate through the IEF layer. Designer Central is the repository for all Solidworks data. Below this, you have the Innovia Core, which communicates with the physical components of the Innovia PLM system, namely the index servers, master control servers, and remote file servers. Let's look at the value proposition of these applications. The Innovia Collaborative Design for Solidworks application offers an immersive and user-friendly interface to manage Solidworks design data within the Innovia PLM system. The primary values are the ability to maintain accurate representations of the intended design, improve design control management, reduce inaccurate data, and achieve ISO compliancy through standardized business processes and design standards management. Innovia Live Collaboration, which represents the core, offers a consistent and intuitive user interface for searching, managing, and navigating product data. It offers full text search capabilities to find, analyze, and refine vast volumes of product information. It also offers pre-built metrics reports to monitor and drive all business processes. In support of Solidworks data management, collaborative workspaces are available for cross-functional and geographically dispersed teams. Innovia Collaboration for Microsoft increases user PLM adoption by allowing users to work in their familiar Microsoft desktop environment to manage documents and other PLM data that relates to the design and engineering process. It offers improved enterprise collaboration by allowing users to easily share files across departments and geographies. In addition, it drives standards by managing and sharing document templates in the PLM platform and records key product decisions by saving and retrieving email threads and attachments in the context of the affected product information. It also improves productivity by supporting the use of familiar Microsoft products to create and author data within the PLM system. Innovia Program Central provides real-time access to project pipelines for rapid analysis and decision-making. It offers real-time reporting on all facets of the projects, as well as process templates with predefined phases, gates, and milestones. It also allows you to manage complex collaborative projects involving internal and external teams of prospects, customers, suppliers, and partners. The Innovia Program Experience is a supplemental layer to the program application. It extends the capabilities of the system to incorporate Microsoft project tools. It also offers a common environment to collaborate on project content and the ability to mass enter and update assigned tasks. You can also mitigate and report status on assigned project tasks, as well as conduct independent project audits. Let's now align the business process of project design with the user profiles and associated Innovia applications. The initial phase of project design begins with product portfolio planning. Here, the product manager can organize and manage product portfolio data. In parallel to this effort, the product manager can maintain project templates and publish global business calendars for enterprise-level scheduling. Project creation and setup is carried out by the project manager. Innovia supports project initiation from standard definitions, creation of project environments, and enablement of and access to project data for enterprise users. Once a product is initialized, resources must be defined and managed. Innovia's ability to do resource requests and resource allocation analysis can be utilized here. With resources established, managers can then begin scheduling phases, gates, and tasks, including assignments. Management of project risks and issues can begin as well. Once the plan is promoted to an active state, team members can see their assigned tasks. They can then update assigned tasks, collaborate, and add project content. For this use case, we will look into the inception of a new design. Designers will review the tasks assigned to them via a project plan. As a project member, designers can browse and review data in the associated project folders to assist them in their work. Let's now take a look at a short video that illustrates this area of the overall use case. Let's take a look at how Innovia Collaborative Design for Solidworks, or SLW for short, can work in a project design environment. Here, in the Designer Central Power View, the users can quickly browse all the workspaces and content that they are linked to via SLW. Via the Task tab at the bottom, the user can quickly access any project plans that they may be assigned to as a resource. The project capability of Program Central allows the designer to quickly understand the overall project and how their tasks affect it. From this high-level view of the project, the designer can expose the detailed project plan, also known as the work breakdown structure. The work breakdown structure exposes the specific details of each of the tasks assigned to the various resources in the project. A Gantt chart is also available to give the designer a quick understanding of the timeline and dependencies. Each project is also associated to a set of folders, similar to those used in the designer workspace. Here, the designer can review the documentation specifically related to this project for insight into their task or tasks. Viewing tools for both documentation, images, and drawings can be utilized from the web client. The designer's relationship to the project defines the type of access they have to IP in each of the project folders. Now, with a clearer view of the tasks and details of the project at hand, the designer can return to their workspace and develop their designs. Now that the project has begun, let's focus in on the mechanical designer and their role in the process. Designers share documentation with the overall product team, such as customer documentation and specifications. Within Innovia, designers can utilize the workspaces to collaborate and revise their designs within their design teams. As their designs progress, they can share their developed IP as specific task deliverables and general information via the project folders. Innovia Collaborative Design for Solidworks allows the user direct access to all the PLM capabilities of the system. IP can be promoted and tracked within the context of the project to completion, with visibility to all project stakeholders. Now that the designer has a clear picture of the related information and the task at hand, they can begin the design effort. Innovia enhances this effort by maintaining the familiar design environment within Solidworks. The PLM system supports the designer, as opposed to getting between them and the functions they need to complete their work. The PLM functionality is supplied through an immersive PLM interface, in that management functionality is only available when needed. To maintain effective design control, one version of the truth is available to all stakeholders. Moving forward with our use case, the designer moves into the Solidworks environment. The designer will manage the IP created within this development effort in workspace folders independent of the project. This will allow the designer flexibility on when and what is released into the project. It should be noted that the designer may work with different users within the workspace than are authorized to the project itself. Let's now take a look at a short video that illustrates this area of the overall use case. From the desktop, designers can access the Innovia workspaces after authenticating themselves to the system. Once authenticated, the workspaces are exposed directly into the File Explorer for access, just like regular Windows folders. As you can see, the file-based paradigm is maintained, allowing instant familiarity for prior file-based users. Note, in the upper panel of the Explorer, the system indicates that files that are unmanaged by Innovia are shown slightly faded. Regardless of the state of the file, the designer can browse and utilize the viewer for sectioning, measurement, and exploded views of assemblies. If the designer selects a SolidWorks component that is managed by Innovia, additional information is made available in the lower panel. The properties of the component, where it is used, and what components it may contain are visible. All this can be filtered based on the SolidWorks configuration. The designer will now open a top-level assembly that contains some of the managed subcomponents. Innovia displays information about the current assembly in a dedicated tab to the right and a preview window just below it. Here, the designer selects a managed component, and we note the additional information in the preview window below. The attributes shown in the preview window can be user-configured. The designer now selects the top assembly so that a new subcomponent can be added. We note that the preview window lacks attributes since it is an unmanaged component. The standard insert command is now utilized, which launches the File Explorer with the embedded Innovia workspaces. This will allow the user to insert managed or unmanaged components as needed. The designer chooses to search as opposed to browse for a component. Any or all of the attributes can be filled in with search criteria to locate candidate components for the assembly. Once the criteria is complete, the search can be executed. Once a component is located, it is simply selected and placed in the assembly in the standard fashion. Once in session, a mate is created to position the parts in the assembly and complete the operation. Once the assembly operation is completed, the Innovia tab updates, indicating to the designer that the newly added component on the local drive is older than the one on the server via color and symbol. To correct the problem, the designer simply right-clicks the component and chooses to get the latest version. The revision information and assembly display are updated accordingly. With no more immediate changes required, the designer decides to check in the work completed. As is true with the Solidworks application itself, commands can be executed from different locations. Here, we see that the check-in command can be run in context of the Innovia panel, an icon in the panel, the command bar at the top of the screen, or the main Innovia pull-down menu. The user may also access the check-in command from the feature tree or directly from the graphical display. Once the check-in operation is selected, a transaction screen is presented to allow the designer specific options. We note that the existing locking lever assembly is being ignored since it is already checked into the system. Once executed, the updated components are uploaded to the server, and the local Innovia display is refreshed to reflect these changes. Once the design has been successfully checked in, all other designers with access to this workspace around the world can utilize it for their related activities and design work. The designer now chooses to create a new drawing based on the assembly. The standard layout is chosen, and the assembly views are added. Once the drawing is completed, the designer attempts to check in the drawing to Innovia, but the command is grayed out. This is because the designer must first save the drawing inside or outside the workspace. Allowing the designer to save the drawing inside or outside of Innovia is important flexibility. It also avoids the perception of positioning the PLM system between the designer and Solidworks. For this scenario, the designer decides to save the drawing within the workspaces, thus allowing the drawing to be checked into Innovia. Now that the check-in operation is selected, the transaction screen indicates that only the drawing will be checked in, since the underlying assembly was checked in during a prior operation. With the drawing task completed, the designer now decides to make a change to the assembly. Once the drawing is closed, the designer checks out the assembly, which is still in session. The tool holder will also be checked out during this operation, so that changes can be made to it in the context of this assembly. Note that the Innovia tab now indicates that two components are checked out by the user. These two components are now locked on the server to prevent change by anyone else who may have access. The designer can now safely make changes to the component in the context of the assembly. Note, however, that the users on a collaborative design can be working with prior revisions of these same components. With the changes complete, the designer now checks in the updated assembly. We note on the transaction screen that only two components, those that have been updated, will be returned to the server. We also can see that new versions of these components will be created, thus maintaining the history of the update. Once the check-in is completed, the designer decides to review the assembly drawing. To demonstrate a capability of the system, a checkout will not be made, so a warning is issued that the drawing is read-only. The Innovia tab indicates that the drawing has been edited by showing a pencil symbol next to the name. The update has occurred since the designer altered one of the components in the assembly. The integration allows the designer to check out the component after he has edited it so that the changes can be captured. This functionality allows the designer or draftsman not to lose their changes in this situation. The designer now completes the operation by checking in the drawing. For reference purposes, the designer now decides to baseline the assembly. This allows them to tag the configuration for future reference. On creation of the baseline, the designer may add a description to better define the purpose of this configuration of the design. Subsequently, this specific configuration can be recalled and retrieved via the history command. With the design work completed, the designer now opens the assembly inside the Innovia system. This is accomplished directly from the interface of the SLW integration. Within Innovia, we see the data that represents the file for the assembly component. Since Solidworks exposes the actual design as a configuration, the instance must be opened to access the structure. The designer can now open a visual view of the assembly structure via the Navigator tab. All the objects defining this assembly are exposed. We can see that the baseline that was created in the client is noted here as well. The system offers a viewer embedded within the web client to allow visual capability to the user community who may not have access to the particular CAD authoring tool that was used. With the design structure selected, the designer can now generate an EBOM. This function will automatically create all the parts representing the CAD designs and create a link between the SW component and each part in the BOM. Attributes can also be mapped to capture information directly from the design properties into the related parts. Once the process has completed, the system indicates that a part is now related to the component via an icon. The designer can now access this part by following the link from the CAD component. Here, we can see all the part properties that define the components. These properties are defined from the CAD information, system defaults, or automation. ERP integration may also be used to assign certain values. The system has also linked the virtual design information to the part so that the engineer can review the parts in 3D as well. Markup tools are also available in the viewing application to share EC data visually. From here, the designer can hand off the EBOM structure to the engineer via an EC to continue the BOM development process. Now that the designer has captured the primary design intent, the resulting IP can be exposed to the project team. Information that should be shared with the team as a whole can be organized into one of the project folders for the team to browse, as was done by the designer in the beginning. Information specific to a specific task can be explicitly linked to a task within the overall plan. Let's look at a short video that illustrates this area of the overall use case. Now that the design work is complete, the designer does a quick review of his design workspace to determine what components and documentation will be uploaded into the project. Returning to the Innovia web client, the designer can review the workspace IP, which mirrors the information that was visible within the File Explorer. From the bottom of the screen, we can also see the task that initiated this design effort. The designer chooses the project itself to review the plan details. Once in the plan, the project folders, which contain all the related project documentation, can be accessed. The designer decides to add an additional document. The designer selects a document that was created during the design process. By adding the document to these folders, it will only be accessible to the other project members. It is uploaded to the server via a wizard, which captures document details for subsequent access. The designer has been prompted for the physical file, and the upload completes. The designer now accesses the task assigned to them. The system exposes the complete details and relationships this task has to the overall plan. The next step is to link the task deliverables to the project that was developed in Solidworks. The designer chooses to link existing documentation, and the search screen is presented. Here, saved and generic searches can be executed to locate all the components that the designer wishes to associate with the task. The designer now selects the complete assembly that was created to complete the task. The designer now returns to the task to update the percentage of completion, which will be reflected in the project leader's dashboard. The project information is always available in real time to all other areas of the system. The project data can be exposed into product portfolios, project dashboards, resource loading reports, and deliverable reports. To summarize, let us review some key capabilities covered in this scenario. The designer and their work are linked to all project stakeholders from plan inception to completion. Designers manage Solidworks data in Innovia V6 through an integrated and immersive interface. Provide multi-site collaboration capabilities, allowing dispersed design teams to productively collaborate on the same design. Grant access for other non-CAD stakeholders across the company to data information in real time throughout the entire product lifecycle via links to project folders. Update tasks and link deliverables as the project evolves. Continuous reporting and dashboard capabilities ensure no surprises if any related efforts get off track.